want to do is I want to show you how to draw the Automation Studio drawing for the bottling station assignment. So we've got 3 cylinders. Here we're going to have some DCVs. In the description, it says something about the fact that you have to use a single acting cylinder with a 3-2 DCV. And then also there's a thing about the swing arm, how the swing arm needs to be moved, like if the power goes out. And we'll talk about that, and I'll show you kind of what selection of components you have and how to solve that. So what I'm going to do is I'm actually going to draw the whole thing right here in front of you. May not do everything exactly, but I'm going to show you some tricks to speed the process up. Now, in Lab 6, which we're going to do in week 7, which is completely online, you're going to study ancillary equipment. And in that lab, you're going to be putting a compressor in, a tank, pressure regulator, and you're going to be running those lines, you're going to be running a line out of the pressure regulator to all of the pressure sources. It'll be a little bit different than the labs that you've done so far where you just stick a pressure source in. So you're also going to be leaning on that lab. Now the thing I'm trying to talk about here is the fact that you've already done labs, Lab 2, Lab 3, and you've already drawn them in Automation Studio. You put all that love into putting the valve port numbers in and all, like configuring everything, cylinders and lines and running all that stuff. And you're also going to, in Lab 6, you're going to be using a compressor, you're going to be putting a tank in, a regulator and all that. Those are 2 different labs. Wouldn't it be nice if somehow you could like stick them together and use those components to build this? Well, I'm going to show you how to do that, and we're going to do that right now. So I'm going to jump right into this and show you how to do that. And along the way, as I'm building this, I'm going to refer to the assignment to kind of like, what do we do here? What does the assignment say? So bear with me, but let's roll. What I've done is I've opened up a previous lab, okay? So I just got this, and the reason I've opened this up is because I've got these DCVs here with all these port numbers and all the symbols, and I've got some metering in here, and I've got this cylinder, and I've got everything else here. So specifically, you know, the big thing is about the label, the texting, and all of the port numbers, which is a lot of work to put in. I don't want to do all that over again. I'm just going to use an old lab, and I'm going to modify it. So what I'm going to do is this drawing. I think I'm just going to take the ladder logic and I'm just going to put it aside because I'm probably maybe just going to rebuild the whole thing, but I'll just kind of stick it over here. And the other thing is that I'm going to need 3 cylinders. So I'm going to grab this whole thing, I'm going to copy it, and I'm going to paste it, and then I'm going to put it down here. So now I have 3 cylinders. Now I can just modify what's here. Okay, so like I said before, I want to get some other information, and that's going to be the ancillary equipment, the compressor, the pressure regulator, and the receiver tank, and maybe a couple other components from the ancillary equipment lab, which is Lab 6, and you're going to be doing Lab 6 in week 7 online. So I'm going to save this project because remember, this is a previous lab that you guys have already built and you've already put all the love into it. So let's just not have to redo all of that. I'm going to save this as the bottling station assignment. So project, save project as, and I'm going to go to here. I've already got it saved here. I'll override it. That's fine. Now what I'm going to do is I'm going to go and open up the ancillary equipment lab that you will be doing in Lab 6. So, and yeah, so let's just wait for this. Open this project up. Perfect. So as this guy is opening, what's happening is that Automation Studio is still running. So this is just a project in Automation Studio. So I can actually just select everything here and copy it. Now I can go and open that other project that I had and then just paste it all in. So because I haven't closed Automation Studio, everything's still in memory. So this is the whole thing from the ancillary lab. I'm just going to zoom in here, and I'm going to say, you know what, I really don't need any of this stuff at all. I don't need this guy. This is a really cool component, and that's one of the really cool components you're going to be using there. I don't know. You don't actually need this guy, but I don't know, I'm just going to keep it. I'm just going to put it over here. So I'm going to get rid of that. So this is pretty much what you're looking for. You don't need this and you don't need that because that's a bleed off valve. We're not going to be doing that. Good. I'm going to take this and I'm just going to put it aside and leave it till later. And what it's going to do is it's going to replace this symbol. Anywhere where we see a a pressure source, it actually indicates that that's actually the entire compressor with the tank and the pressure regulator and everything else. So we're going to add those things into all labs moving forward after the ancillary equipment. And again, you can open up, say, lab 4 or lab 5, and then save it as lab 7, and then open up the ancillary equipment lab, grab that, copy all of the regulator and the tank and the pressure and the pump and whatever, and then paste it into your new lab 7. Yeah, there you go. So that's a good trick that really will empower you in the future and save you a lot of work. I'm just going to start cleaning this thing up and modifying it to be the Automation Studio drawing for the bottling station assignment. I think the first thing I'm going to do is rename it. Definitely going to sneak this in because you don't want those huge text boxes. And I'm going to show you a problem with text boxes getting in here and there. Now this is cylinder A. I'm going to call this the clamping cylinder. So I'm just going to call it C. Now the problem is this text down here says A. But now look at this. I can't grab that because it's right inside here. So I'm going to try and do this. I still can't grab it. I may be able to grab it if I do that. I did grab it. So I'm going to put it out of the way now. I'm probably not going to be able to grab this one. No, I'll show you a trick. Just try and grab it and then go here and pull this up and then click out of here. And now I can actually move this out of the way. So text box get in the way, and when you try and put one box over another, it creates a problem. I'm just going to say C, and then I'm actually going to stick that like right here. I'll change this guy. And that's C, and then I'm going to put it over here so I can grab it on its own. Yep, I can grab that without actually grabbing the valve. Actually, I think I can put that in a little closer. Good. So there you go. I've got that changed. Now I can actually take this and rename these solenoids, but it's actually a lot quicker for me just to delete this guy and put a new one in. But you see, all of the port numbers are still there, and everything's already aligned. So I'm just going to leave that. So I'm going to go for some directional valves, and I'm going to go for a 5.2, pardon me. So a 5.2 valve, and I'm going to use this one. There isn't one in the library that's automatically got, it's automatically got a double solenoid. That's all right. I can just click on this and then turn it into a solenoid and close it up, and I'm good. Yep, save changes. Perfect. So now I've got that, and that's good. I'm going to name these guys later once I start doing the ladder logic. But for now, I want to clean this up, and I want to make it as close as I can as far as the components go for the bottling station. So that's the clamp. Now what I'm going to do is I'm going to go over here, and this is going to be my capping cylinder. Now I'm actually going to call that P because I can't, if I called it C, that's a little bit weird. So capping, punch, maybe a punch cylinder, a cap, I don't know. Whatever you want. I mean, it's actually discussed in the assignment. It actually calls punching, no, pardon me, it's called capping, and then I think cap punching, whatever. So P works. Again, this guy I'm going to delete, but I want to also think about what is required from the lab, so from the description of the project. So I'm just going to go over here now, and I'm going to share my screen here. Now, the clamping cylinder is a double acting cylinder, and it's going to need a 5.2 DCV with double solenoids. I just know that. But in this case, I got a different situation. I have to use a single acting spring return cylinder. Now, this is a pretty cool situation here. Once you read this, you'll understand exactly what's going on with the capping cylinder. And it has to do with the alignment and stuff. But right now, I just want to focus on drawing this. So this is what we need to draw. You know what? You can actually just copy this and paste it in here so that you've got an idea of what you have to do, and then you can delete it later. Or you can just take a little screenshot of that and put it here. So what I know here is that I do not have any metering. And we'll talk about metering in the ancillary. No, we'll talk about metering in the ancillary lecture, which is in week 5. So you'll have a really good understanding of that. And I can change, I'm going to move these out of the way now because I know that I had a bit of a problem capturing them. And right now I'm going to choose the correct DCB for this. It's actually a 2.3 DCB, and actually there's one right here. I want to make sure that I place it properly because I want the exhaust to be on 3. So I'm going to put that there, and I don't need this guy, and I'm going to delete that. And this cylinder actually has to be changed. So I'm going to delete that cylinder, and I'm going to delete this guy and this guy. We'll work on limit switches later. So I have to go find the right actuator for that. And that is going to be a single acting actuator, and it's a spring return actuator. So I'm going to put that there, and I'm going to put that right up with this limit switch. I may want to move some stuff around later, but right now my focus is to get the components in, especially to like allow my brain to go, okay, I think I got this. Now I can clean things up. Just focus on getting the parts in first. And before you move stuff around, I guess I can move this up a little bit. Okay, good. So now I know that this is going to be a P, and it's going to be a P plus, and I'm not going to need this guy because I don't have another solenoid. So I'm just going to stick that over there. Okay, good. So now these limit switches, we have to think about the limit switches for this punching cylinder or the capping cylinder. Essentially, I think the best limit switches are going to be reed limit switches. You could use a mechanical limit switch in the return and then a reed switch on the extension. Let's do that. I'm going to get rid of this guy. Bam, he's gone. Okay, good. So I'm going to get rid of that. And what I'm going to do is I'm going to go into my sensors. And I'm going to take a look at sensors, and there's a reed switch right there. I'm just going to dump it in, and when I do dump it in, it's going to ask me a question. First of all, actually, I'm going to put this over here for a reason, and I know that because it's going to be P plus. The reason is because, actually, I want to rotate this. You know what? Now that I'm thinking about this, I'm kind of thinking I could still use a mechanical switch here, but it's probably best if I just use a reed switch because it's just smaller, and the capping cylinder, I can just place it right on the cylinder. Okay, good. So that's LSP minus. Perfect. Okay, good. So now I have to rotate these because this cylinder also has to get rotated because it's punching down. So I'm gonna move that. I'm gonna take this guy, put this out of the way. I'm actually gonna delete this line. I'm gonna take this and put this up here. I'm gonna hit Control H. I mean, I've been using this software for a long time. I know that I can just hit Control H, but I'm going to hit undo, and I'm going to show you how to do that by not doing that. You can do transformation, and you can do rotate right. Good. So I'm going to have that because it's punching downwards. So now what I've got is I've got these guys, and they have to be rotated as well. I'm just going to hit Control H. Perfect. So now I'm going to stick this guy up here. Now, for me to get the position of this properly, I don't know, I'm just going to guess that it's there, but I don't really know. I'm going to click on this, and then I'm going to go to Data, and I'm going to extend it 100%. So in extension, I'm going to go 100, and it will extend, and then I know where to place this. If I zoom in here, I didn't quite get it right. Okay, there you go. So that's how you know how to place it. And then what I can do here is I can just click on this guy again, and I can just say 0, and it will retract. Good. I'm going to get rid of this because I don't need that. And now I'm going to maybe just stick this guy up in here somewhere. I'm going to zoom in, and I'm going to put this here. Nice. So I don't need any metering on this because this guy is going to, I just got that, didn't quite right. There, it's got to look pretty. It's got to look good. When someone looks at your drawing, all of the positioning and everything has to feel good. They have to, the geometry has to feel good because they have to like your drawing. Really, that's a big part of presenting information. Someone's got to just, like, they don't even know, like, they're not going to be like, oh, that's such a pretty drawing. No, they're just going to look at it and they're just not going to feel like, oh, that line goes all crooked and weird and this just kind of seems out of place. No, it's got to just feel right. Okay, good. So, when I moved this, I had a problem. And it looks like my port numbers got all moved too. So I'm going to grab all of these. I'm going to move that up there. I'm going to grab all of these. Oops, daisy. My port 2 it just disappeared. I don't know what happened to it. But I can grab, ooh. See, it's difficult. I want to grab just that 5. Oh, I got it. I'm going to go over here and grab a number 2 because oops, daisy, hit escape. Escape is a really good button. Copy, awesome. In Automation Studio, nice. Okay, that's going to go right there. It's funny, it's kind of jumping around a little bit. You can use your arrows to move things as well. There you go, that's good enough. Okay, perfect, here we go. So we've got our port numbers. This guy's all set up, and that doesn't need any metering. What metering does is it slows the cylinder down in extension or retraction. Actually, let me pause and talk about metering because it has to do with timing. So if we actually take a look at the description and we go to timing, we can see that certain cylinders take a certain amount of time to extend and or retract. So the clamping cylinder that grabs onto the bottle, it actually takes 3/4 of a second to extend. Now, if it was like moving at full speed, it might take a 1/4 second, even less, or half a second. But it's probably metered because you don't want to just smash onto that bottle. You want to kind of just kind of clamp it. You don't want to come at it too quickly. So the way to do that is to slow it down. So anywhere where you see that a cylinder takes a certain amount of time to extend and or retract, there's metering there. So you want to put metering where you see those numbers. For instance, here, okay, so for the swing arm cylinder, it takes 1.5 seconds to extend and 1 second to retract. Okay, so it's going to extend a little more slowly than it will retract. So you're going to have to put metering on both sides. And let's take a look at the punch cylinder. There's no metering at all. Okay, good. So we know there's going to be metering on the clamping cylinder in extension, but not in retraction, because timing is everything when we're designing these pneumatic systems or any automated system. Like, you know, a 1/4 second at the end of a day adds up to half a minute, and then a half a minute over a week adds up to much more, and then over a month, much more, and at the end of the year, a 1/4 second is going to cost you $1,000. So you want to just dial those times down. You want to really accurately, wherever you can, to make time shorter, it's fine. So the cylinder in extension has to be metered, but in retraction, you just get it out of the way because it's got to get out of the way so the next bottle can come in. Okay, good. So moving on, we know that the capping cylinder is going to have to be slowed down in extension. Now, the way we do that with metering is we slow that down. I'm going to get rid of this and this. We slow it down by putting metering on the output port. And we'll learn that in the lecture, ancillary equipment. Okay, good. So I had a pause there. Okay, good. Yeah, that looks good. That looks good. You know what? Just for a little, I don't know, just a little bit. I'm just going to take this and move it down a little bit. I don't know. My brain just wants to do that because it just feels like they look good. So, for instance, if I had this and I stuck that up there, that wouldn't feel right. It just kind of doesn't look right. So you know, put some love into your work. I just hit Control Z to get that out of there. Okay, good. So now for my clamping cylinder, definitely I'm not going to have an outside limit switch because that's going to get in the way, or mechanical limit switch. It's going to get in the way. For the retraction, I can put a mechanical limit switch in there. So I need to put a reed switch in here. So I'm going to dump this in here. You know what? I just know where this goes. I'm pretty sure it goes right there. So that's limit switch clamp plus. Perfect. Okay, I'm going to roll with that. If my simulation doesn't work, I know that I haven't placed this properly. Actually, you know what? I don't think I did. I don't think I put it right. Let's check it out. Let's see if I can get that extension 100% just to check to see if I got it. I did. Okay, I'm going to hit Control Z, which just takes it back. Saves me having to go in the menu. Awesome. So I think I've labeled stuff here. Oh, I've got to label this guy. Actually, that was just, oh, do you know what? Let me tell you something. I'll get rid of that. That is a font. I mean, that's a text box that I added in. I can delete that because when I name this, it's going to be named, the name will be beside it. Now, what I'm saying here is that it's probably best just to delete this and put a new one in. And the reason is because for me to go in and rename that, it's actually a lot of work. So I'm just going to hit delete, and I'm just going to throw a new one in. Now it'll ask me what the limit switch name is, and that's limit switch C minus. Oops, that's not what a minus looks like. Perfect. Okay, good. Yeah. All right, so now this guy is going to be the swing arm cylinder, and it'll be an interesting, we can use mechanical switches here. You know what, I'm going to delete this and this, and it's going to be interesting to talk about, you know what, I don't want to delete that just yet. And the reason is because I'm going to be able to place the other one in the exact spot if I leave that there. So the DCV in this case is going to be pretty cool, and we'll talk about that. Let me just throw another limit switch in here. Now thinking about the swing arm cylinder, one way or the other, it's extending and retracting. I don't know. I'm gonna put a reed switch on one side and a mechanical switch on the other. When you physically go and build the thing, you may find that it works better the other way. I don't know. I'm gonna put a reed switch over here. The reason I'm doing that is because LS, the swing minus, is because it's easier to place it. If I put it out here, I'd have to extend the cylinder. Okay, good. So, like I said, it doesn't really matter at this point because I don't really know. Limit switch sing S plus. Now I'm gonna grab this and delete this. I'm gonna take this and just push it down by 1. So I use the arrow keys to move things around. You know what? I don't think I got that right. I'm going to do the arrow key one more time. Yep, that's definitely going to be aligned. I know that it's the right distance out because I put it exactly where the other one was. Let's put in the DCV. I'm going to delete this guy, and then that allows me to take this text box out of the way and this text box. The reason I'm deleting it is because let's take a look at the operational specifications for the swing arm cylinder. So the swing arm cylinder, actually it has to do with the design specifications. And that is all about the safety, or more specifically, what we call fail-safe. So if a system fails, you want it to fail safely. You want it to fail so that the failure is not going to be catastrophic. In this case, if the power goes out or if the pneumatics go out for whatever reason, we don't want a cylinder stuck in extension or stuck in retraction. That swing arm, what it does is it's got the capping cylinder on it. So it'll swing over, and then the capping cylinder goes, and then it swings back. We want it if the power goes out and it's right over the bottle. I want to be able to pull it back manually. But I think, as you guys know in the lab, when a cylinder is either in extension or retraction, you can't move it. I mean, the pressure is constantly pushing it in extension or constantly pushing it in retraction. But what do we do if we want to just be able to swing it one way or the other? Well, use a 3-5 DCV. So a 5-3 DCV, a 5-port 3-position DCV. And that's in this discussion here. So that's pretty cool. And more specifically, the center is going to be a pretty cool center. It's going to be an open or a passing center. And that's going to allow the air to pass through. It's going to allow air to go in and out of the cylinder as it's physically being moved one way or the other. And essentially, it's just open to atmosphere because both of these are going to be connected to exhausts. Let's just go in Automation Studio Drawing and Automation Studio and plug it in. Good. I'm going to go to my DCVs. I'm going to go down to directional control valves. I know it's a 5-3, and it's a spring-centered. Most certainly. I haven't actually ever seen the use of a 5-3 that's not spring-centered. And the reason is because, when you turn either this off or this off, whether this is a push button, a pilot, or a solenoid, or a pilot-operated solenoid, whatever that is, however it works, when you don't activate either or, it springs into the middle. It pushes into the middle. And the springs are necessary. Now, what I want to do is I want to change this. Let's just take a look at this so you can understand what I'm talking about. If I were to physically try to move this cylinder right now, I couldn't move it. I couldn't pull it out. If it was extended, I couldn't push it back. The reason is because it's blocked. The air can't go in either this port or that. It can't get through the DCV. So I'm going to double click on this guy, and then I'm going to go into my builder, which is technical specifications. Yeah. So, and I'm going to double click on the middle, and I'm going to change the center position of this DCV. And I'm going to find the passing or open right here. There you go. Awesome. So I will close that, and it's going to save. And there you go. Perfect. So that's done. Now we know that I can change this font. So I was smart to move that out of the way because I think I would have struggled getting it out of there. So that's S. And this guy is also S. Perfect. Now, we do want metering on this. We want metering for sure. You want the metering in here. So you're going to leave it because it's going to extend, and it does say that it takes 1.2 seconds to extend. And it takes 1 second to retract. If there was no metering, it would extend and retract really quickly, like within a quarter second. And you've seen the cylinders move in the lab. They move really quickly. Okay, so this is future me. I just want to pop in here and mention something about the metering. You don't have to, you can adjust the metering in Automation Studio, and you can adjust that. But essentially what's going to happen is that often in hydraulics and in pneumatics and fluid power, when we put anything that's physically adjustable by hand, often what we do is in the field, once we build the thing, we look at the specs and we say, oh, the cylinder is supposed to extend over 1.2 seconds. Okay, so you run the cylinder and you tweak the metering a little bit until it does take 1.2 seconds to extend. Now, if you want to actually do that in the Automation Studio, in the simulation, you can go ahead and do that if you want. I'm not going to check it. Your instructors are probably not going to check it. As long as there's metering there, you're good, because essentially you're building a schematic. It's supposed to work. I mean, if we were studying flow rates, yes, we would want to put metering in that actually made it extend over 1.2 seconds or retracted over 1 second. But we're not doing that. So you don't have to tweak and fool around with the metering until it gets the cylinders to extend exactly at that amount of time. You're good. So that's good, and I think that's it. I think as far as all of the cylinders go, I can delete this guy. I don't need this guy. As far as all the cylinders go and the valves and the ports and stuff, I think everything's good here. Now, the one thing I want to do before I stop this video, because I'm going to do another video on how to design the ladder logic, is I want to get rid of this. And I want to get rid of this. So bear with me for another maybe 4 or 5 minutes. And then we will be done the Automation Studio, at least the pneumatic portion of the Automation Studio. I'm going to put this guy over here because that's consistent with all of the rest of them. So now I want this guy and I want to pull him up here. Now, what you want to do is you want to think about the fact that this has to actually go into your report, and you're going to take a screenshot of it and you're going to put it at the bottom of your report. In your appendix. So you want it to be more landscape looking and portrait looking. I just lied to you. You want it to be more portrait looking, up and down, right? So I'm going to probably move some things around. This logo is really nice to have here. You know how I got that? I'm not kidding. I just went to the Humber website, and the Faculty of Applied Science and Technology, and I just zoomed in and I took a screenshot, and then I just kept that, and I cropped it all nice and pretty and really just to the edges using paint. And then now I have that and I put it in everything. That's where I got it from. I didn't get it from some official source. And you can do the same because it's a Humber drawing. You can put the logo on it. Bottling station, I'm going to put that here up there. Now this guy I'm grabbing the whole thing and I'm going to put him over there. I want to put it along this. So these are about the same height apart. And I don't know, I may kind of manipulate this a little bit. You know what, I'm going to move this out of the way for now. Let's grab this and let's put this in. I'm going to zoom out so I can get a better look at it. You know what, it's kind of looking good. It's kind of looking good. So now this, I can put here. Now, there are 2 pressure regulators here. And the reason I put 2 of them is because we're going to need 2 pressure regulators. Because if you read the project description, it talks about the cylinder forces. So the cylinder forces, the clamping cylinder is applying 4 pounds of PSI, 4 pounds of force. By the way, the pressures you're going to calculate here are really low. And that's because we're dealing with glass. So it's going to be 3 pounds of force. And actually, this guy, do you know what? I'm actually changing this right now. It's going to be 8 pounds of force. So you're going to have to calculate for 8 pounds of force. And the reason we can apply 8 pounds of force for the cap is because the cap, or the punch cylinder, is not a clamping cylinder. No, it's just going to, and you can read the description about how the function of this works. It extends all the way. Once it goes all the way, it doesn't keep pushing on the bottle. It's designed and aligned so specifically and accurately that it only pushes the cap on and then it stops pushing. So you can apply a lot of force on that. So you nicely, good, hit that cap really hard. You're not going to break the bottle because you're not squishing the bottle. You're just pushing the cap exactly on the bottle. So I'm going to have a higher pressure for my capping cylinder and a much lower pressure for my my clamping cylinder. So what's going to happen here is that this guy over here, let's just say that whatever that's going to be, whatever this pressure is going to be, I don't know. I'm gonna put a double number there because it's gonna be bigger. Oh, I don't know what just happened. So there you go. So now that is going to go to the capping cylinder. Nice. I'm going to take this. This is kind of working out. It's actually the space and stuff is working out pretty good. Good. So that's working out, and that kind of looks pretty and it's nice. This guy, I don't think I'm going to need him. I'm just going to leave him there because I can take it out finally before I submit this thing. I can just take that out. That's pretty cool. That's a ball valve, on-off valve. Now, this guy is going to be a lower pressure, so I don't know what that is because you guys haven't done the math yet, but that's all right. I'm just going to put a single number there indicating, it's not a number, but whatever, we'll just leave that, dollar sign. Now, this is going to come down here. It's going to go along here, up here, and there, and this is how we do a T. You can actually go and get a node in here somewhere and stick it in here, but I just do this. I'm going to take this, I'm going to take this down here. Yeah, I guess I can go through the drawing. I don't like it because when the cylinder extends, I don't want it going over hoses. That looks pretty good. I think that's okay. And I've got my pressure regulator there. I've got my my tank or my receiver, and I have my compressor. And you guys are going to set the dimensions for this stuff. Actually, you're going to set the compressor specifications in here. So that I think they're probably going to be fine for this bottling station, because we're not talking about flow rate for this bottling station, so you can leave whatever the settings are, you can leave them. Okay, good. So that looks pretty good. You know what? I think I can clean this up a little bit by just moving this up. I'm not sure if I can. Again, I'm really thinking about, like, it's got to look good, right? And I got to be able to squish it into, you know what? I'm just going to hit Control Z and Control Z. I'm going to delete this. Then I'm going to grab this and I'm going to pull it up a little bit to about there. Good. And I'm going to redo this. Good. Now that, if I take a screenshot of that, actually, do you know what? I'm going to grab this whole thing. I'm just going to move it over a little bit. Actually, I have to move. I'm going to grab this guy too. Yeah, I'm going to move over it a little bit. I'm going to go over to there. Good. There, that looks good. Now I can actually just take a screenshot of that. I could do this. And, you know, I would crop that personally. You know, I mean, I want, you know what? I want to make sure that when I'm going to put a drawing or a screenshot or whatever, any drawing or whatever into a document, I want it to be, I don't want to have a lot of extra space on top of it. So what I do is I throw things into Paint. So I can just do this and I can clean it up a little bit. So when I do place it into a Word document, it actually, all that extra space is not there. So I'm going to grab this guy, select all, copy. You can just save this, save it as a drawing, and then put it somewhere, and then just go paste, boom, paste it right into your Word document, and put it right in the appendix, and you know, and then it'd be good. Okay, good. So of course, do that after you've done the ladder logic. When you do the ladder logic, these guys will get named. I think we're good. That looks good. So my next video is going to be about how to do the Automation Studio. You guys know how to do the Automation Studio, like ladder logic, but I think I'll do a video about like thinking about how to design something like this in ladder logic. You've already done some ladder logic designing, so you guys are good at that. At least you have some experience in that, and I think I'll give you some tips on kind of, how to think about when you're doing your designing. And that's it. Okay, bye.